Welcome dear students, we are on the CEC Gurukul lecture and we are discussing the electronic circuit, in which we are discussing one of the important component, that is the magnetron. In the magnetron we are defining that it is used for generation of this, it is worked like as a vacuum tube, and here we are discussing about the its construction and its working operation. Now in the working operation, the two phases we have defined in the previous lecture. Now we discuss the third phase. In the third phase, there is a formation of the space charge wheel, as it works as a space charge wheel. How it is work? It is a rotating charge wheel in an 12 cavity magnetron. You are seeing on the screen that there is a cavities, and these cavities are just attached with the vanes, and these vanes you can clearly see that there is a space charge generation, and this space charge generation, when we apply the electric field as well as we are just keeping it in the magnetic field. And then one reason of the different speed of the electron groups and the velocity modulation leads to a density modulation therefore. So, cumulative action of many electrons returning to the cathode while others are moving towards the anode forms a pattern that resembling the moving spokes of the wheel. That is why it is called the space charge wheel. There is a cumulative action of many electrons which are returning towards the cathode while others are moving towards the anode, and that pattern will be formed that resembles like a spokes of a wheel. That is why it is called a space charge wheel. The space charge wheel rotates about the cathode at an angular velocity of the two pole, that is the anode segment per cycle of the AC field. You are seeing here that this rotate in the per AC cycle, and it is rotate in the form of the like the angular velocity. So this phase relationship enables the concentration of the electron to the continuously deliver energy to sustain the RF oscillations. So one of the spokes just is near an anode segment which is loaded and little more negative. The electrons are slowed down and pass her energy to the AC field. If we talk about there is a phase relation which enables the concentration of the electrons to the continuously deliver energy to the RF oscillations. So in which one of the spoke just is near to an anode segment which loaded which is loaded a little more negatively. So the electrons are slowed down and pass her energy to an AC field. So this state isn't static because both the AC field and the wire wheel permanently circulating. So we cannot say that it is a static field, but it is a permanent rotating. The tangential speed of the electron spoke and the cycle speed of the wave must be brought into agreement for this. That is why it is moving. So in the phase 4, just we have it dispense energy to the AC field. As AC field is generated through this magnetron, so how it can get this energy. So the electron moving against the electric field is accelerated by the field and takes energy from the field. So an electron dispenses energy to the field and slows down if it is moving in the same direction as the field, like from positive to the negative. So electron spends energy to each cavity as it passes and eventually reaches the anode when its energy is expended. So thus the electron has helped sustain the oscillations because it has taken energy from the DC field and given to the AC field. So the electron this electron describes the path over a long time period. Look, by the multiple breaking of the electron, the energy of the electron is used optimally. So, effectiveness reaches up to the 80%. So, what is this transient oscillation? After switching the anode voltage, there is still no RF field. So, if there is no RF field, so the single electrons moves under the influence of the static electric field of the anode voltage, and the effect of magnetic field that we have shown in the figure by the red electron path that we will show in the next slide. So, electrons are charge carriers, as during the flyby at the gap they give off a small part of energy to the cavity. Similar to the fluid, a fluid produces a sound when the stream of the air is flowing past as an edge of the hole. So, during the flyover of a gap, as you can see that there is a after switching the anode voltage, there is still no RF field. So, single electron move after the influence of the static field, and anode voltage and the effect of magnetic field we can see in the path. Because of that, the fly by a gap, they give off a small part of the energy to the cavity. So, the cavity resonator begins to oscillate at its natural resonant frequency. So, in this case, it immediately begins the interaction between the RF field, which is having the very low power, and the electron beam. So, there must be interaction between there will be interaction between the RF field and the electron beam. So, the electron beam are additionally influenced by the alternating field, and it begins process and will described as a sequence of phase 1 to 4 of the interaction between the RF field and the velocity modulated electrons. So, in this manner, from the low to high it will work, it will start working in the 4 phase, and that phase where just we are having the 4 phases, in which the first phase that will be the that will be the production and the acceleration of the electron beam in a DC field. In the second phase, velocity modulation of the electron beam. In the phase third, there is a formation of space charge wheel, and in the phase 4, dispense energy to the AC field, and that is the objective. That how we get the AC field from the production of acceleration of the electron from the DC. It means here we are converting the DC field to the AC field by generation of space charge. So, this is the basic function of the magnetron that will work on the 4 phase. And after that, the transition from DC to AC, there are the 4 phases. The transient oscillation does not begins with a predictable phase. So, each transient oscillation occurs with the random phase. The transmitted pulse that are generated by the magnetron are therefore not coherent, they are not in the phase. So, what are the modes of oscillation? An anode segment are represented by unbound. So, you can see these are the mode of oscillation, how it works. So, pi mode, 1 by 2 pi mode, 4 by 4 pi mode, 3 by 4 pi mode. So, these are the mode of oscillation according to the degree of oscillation, like pi mode and 1 by 2 pi mode, 1 by 2 pi mode, and here the 3 pi by 4 pi mode. So, you can see that there is a movement of that is the strapping, as you can see in the diagram, that the cut view of a magnetron, that is type A vein type, and we are showing the strapping ring and the slots. You can easily see that is the actual picture, strapping which is which is showing the rings and the slots that are attached with the anode, with the vanes also. And apart from this, the operation frequency depends on the size of the cavity and the interaction space between the anode and cathode. So the generation of the DC field to the AC field, operation of this magnetron frequency, which depends upon the size of the cavities and the interaction size of the cavity and the interaction space between the anode and the cathode. It means whenever we change the size and whenever we change the interaction between the cathode and anode, the frequency will change. So whenever we require the frequency change, we change the size of cavity as well as we change the interaction and the anode and cathode. But the single cavity are coupled over the interaction space with each other. Means if we are taking the single cavity for the coupling over the interaction space with each other, several resonant frequency exist for the complete system. So whenever we take the output, then all the resonant cavity will work together so that a particular frequency, a fixed frequency we can get. Two of the four possible waveforms of the magnetron with 12 cavity we have shown in the previous diagram. So several other modes of oscillations are possible, as we have discussed in the previous figure, that there are the 3 pi by mode, 3 by 4 pi, and moreover 1 by 2 pi and 1 by 4 pi. But the magnetron operation in the pi mode has greater power and the output is the most commonly used. So two constructive measures are possible for this. Number 1, stepping rings. The frequency of N mode is separated from the frequency of the other modes by stepping to ensure that the alternate segments have identical polarities. Like if we are having the one change, if I am having a 12 cavity, and then if we change the frequency of the pi for the pi mode to the frequency of the other modes by stepping to ensure the alternating segment have identical polarities. So for the pi mode, all parts of the each stepping rings are at the same potential, but the two rings have alternating position, opposing potential. Means if we take that the 2 or 4 possible waveforms of the magnetron with the 12 cavity, we will represent previously, where we define the 3 by 4 pi, 1 by 2 pi mode and 1 by 4 mode. But the magnetron, if operate in the pi mode, has a greater power and output and is most commonly used. So if it work in the pi mode, then it will give the fixed output. So the stable operation condition adapts in the optimal pi mode. To constructive measurement are possible, in which first we have defined the stepping rings, where the pi mode, all parts of each stepping ring are at the same potential, but the two rings have the alternating opposite potential. Means we change the potential of the different rings in case of the pi mode. For the other modes, however, the phase difference exists between the successive segments connected to given stepping rings, which causes current to flow in the steps. Means if we talk about the stepping rings, the frequency of pi mode is separated from the frequency of the other modes by stepping of ensure that the alternating segment have the identical priorities. So in the pi mode, all the parts of the ring having the same, but we can change only the two rings with the alternating opposite potential. But if we talk about the other modes, the phase difference exists between the successive segments connected to the given strapping ring will causes the current to flow in the straps. So what is the use of this use of cavities of the different resonance frequencies? Means we use the cavity with the different resonance frequency, then what will give to the better output. Each give a variant in the anode from rising sun. Means each a variant is a anode from rising sun. Each anode will work for the starting of the magnetron. So in the magnetron coupling method, what happened in the magnetron coupling method, energy, that is RF energy, can be removed from a magnetron by means of the coupling loop into the bottom of the one resonator. So at the frequency lower than 10,000 megahertz, the coupling loop is made by bending the inner conductor of a coaxial line into a loop. So in this case, when we apply the magnetic field, the frequency, the bending of the beam will take place. So the loop is then soldered to the end of the outer conductor so that it projects into a cavity, and that cavity we can see here. You can see magnetron coupling here, that the two magnetrons are coupled together. So in which the frequency lower than the 10 megahertz, the coupling loop is made by the bending the inner conductor of a coaxial line into a loop. Similarly, this loop is then soldered to the end of the outer conductor so that it projects into the cavity. So locating the loop at the end of the cavity causes the magnetron to obtain the sufficient pickup at a higher frequency. So you can see that it is connected at the outer edge. So this is A and this is B. Magnetron coupling has been taken place. Magnetron coupling view for the various positions, you can see here. This coupling has been done. You can see here the coupling can be done in the various form. So the segment fed loop method is defined here. The loop, there is a segment fed loop. The loop intercepts the magnetic line passing between the cavities. So the strap fed loop method intercepts the energy between the strap and the segment. These two will be intercept. So one on the output side, the coaxial line feeds another coaxial line directly or feeds a waveguide through a choke joint. There is a choke joint, then we feed from one waveguide to the another, then we will use that. So the vacuum seal at the inner conductor helps to support the line. Moreover, the aperture or a slot coupling at there is a slot or a coupling. Energy is coupled directly to a waveguide through and that is made from iris, that is from the glass or the ceramic. Another is the magnetron tuning. How will tune the magnetron? A tunable magnetron permits the system to operate at a precise frequency anywhere within a band of the frequency as determined by the magnetron characteristics. So the resonant frequency of the magnetron may be changed by varying the inductance or the capacitance of the resonant cavity. So that we can change the resonant frequency of a magnetron by changing its inductance and the capacitance of the resonant cavities. You can see this is the inductive magnetron tuning. We can change it we can increase or decrease it, then automatically the frequency will change. This is the inductive magnetron tuning. So, in this figure we are having the resonant cavity of an hole and the slot type magnetron with inductive tuning element, and you can see here. And if we take the example of the tunable magnetron is the M5114B, which is used for the radar. To reduce the mutual interfaces, the ASR 910 can work for the different assignments. So, frequency of transmitter must be tunable. Therefore, this magnetron is provided with a mechanism to adjust. It means the frequency can vary and accordingly we can have it. So, that is the inductive tuning element of the TH3123 magnetron. These are the name which are used in the ATC radar systems, and they are the most of different type of the magnetron are used in the radar system. Note that the adjustment of the filament supply lines, resonant cavity and the coupling loop cavity are not tunable. Coupling loop cavity are not tunable. So, there are the various type of resonator. You can see there is a magnetron. This is a radar ASR 910 ATC radar ASR 910 that are used for the transmission of the signal. Moreover, this is another type of the magnetron VMX1090 of the ATC radar PAR 80, and this magnetron is even equipped with the permanent magnets necessary for the work. So, these type of magnetron we will use for the various circuits. Moreover, just we have taken the sources, this lecture taken from the sources from the magnetron, and these magnetrons used in the microwave. There are the many application of this magnetron that we will discuss in the next lecture, in which we define the one by one how this magnetron work in the microwave system, how this work in the radar system, how it will work in the various electronic equipments, so that we can we can easily understand the working principle of this magnetron. Thank you very much.